Hey, this is Mr. Lowe. Welcome, mathematicians, or future mathematicians. What we're going to be doing today is called parent functions. So I've already printed out a graphic for you guys so that you can kind of see what these parent functions are. And we're mostly going to talk about the first six, and we're just going to not worry about these other guys here, but it was a good graphic, and it showed the other parent functions that we're going to maybe look at some other time. Alright, not that guy and not that guy. So, if we look at our parent functions here, the first one we're going to start with is this constant. So the constant is just f of x is equal to some number. In this case, it'll be like f of x is equal to, it looks like 1.2 about, So that's just a straight horizontal line. This line will not be vertical, or at least it won't be vertical when we have, that's a point, when we have a function. So just make sure that if we have f of x is equal to some constant, that we have a straight horizontal line. Okay, next one we have is going to be f of x is equal to x, which is a linear function, right? So this says identity function here, but linear function is fine. This is f of x is equal to x, right? So you can see it right here. It's going to be a diagonal line going from left to right, so lower to higher. So it's going to be in this way, and we're going to talk about a different diagonal function that way later. But for now, this is going to be linear function f of x is equal to x. Next we have absolute value function, which is going to be f of x is equal to the absolute value of x. So those lines there is an absolute value symbol. And what it means is that for all these negative values of y, so if we took all of these negative values of f of x here, and we made them positive, it would look like this guy, right? So this whole leg down here would be brought up and moved diagonally this way. Next we have f of x is equal to square root of x, and notice that this is like a half of a line, right? So we're going to talk about x squared in a moment, but this is a sideways x squared basically, and notice it's only the positive side. So the positive side, it's only the positive side because we're talking about functions here. So if you want to turn that into a y, we can talk about this is guy like y is equal to plus or minus x squared, and that would be the whole parabola. But for right now, we're just going to keep it positive. So we're talking about functions. Functions is just the positive x square root x. Next we have a quadratic function, right? So this guy is going to be a quadratic. It's a parabola, which we've seen before. So this is going to be f of x is equal to x squared. So it's a parabola, and we're going to look at that in just a little bit. This one is a cubic function. So a cubic function is our last function we're going to look at. It is going to be curvy line, it's a cubic. I don't know how to describe it, but basically it's a parabola where this left hand side has been flipped upside down, kind of, not really. We'll see why in a little bit, but you could play with Desmos or GeoGebra later if you feel like it, but that's what we're looking at for right now. Okay, so let's take a look at our first example here. And what I wanted to do is take a look at what it looks like to actually graph a parent function, right? What do you need to graph a parent function? What am I looking for when I'm talking about the critical values and all that kind of stuff? So let's start. Let's see here. So I've drawn a little bit of a axes right here. So make sure that when we're drawing these axes that we have a pencil for one, and our pencil is working. There we go. And these are actual axes here, and that we are making sure that we label our axes. So that's my y value, that's my x values, and we're talking about f of x is equal to x squared. So on my table here, I'm going to put an x, and I'm going to put an f of x. Okay, so then I hate to use this analogy, but if we want to think about it, our little function machine, we input an x and we output a f of x. Okay, so first thing we want to do is start with some critical points. So when I'm talking about critical points for these functions up here, we are talking, let me get a different color. Let's pick up nice blue here. This is going to be my critical point down here. For this guy, it's going to be right here. That's going to be my vertex. On this guy, this is going to be my critical point. And this guy is going to be my critical point. And this guy is going to be my critical points. So those are my, okay, so those are my critical points in blue. Let's go back to black here. Okay, so those are my critical points. For this guy, so for an x squared, we're going to talk about a critical point. This one is going to start at 0. It's always a good spot to start at. So we're going to have a 0. And if we plug in 0 into f of x, so we have 0, that's going to give me a 0. Okay, so I'm going to fill in a 0 here. Well, that's good. That should be this point right here. And that is our critical point still. So let's pick a different number. Something a little bit more interesting. Let's pick a 1. That's going to be 1 squared. And that's going to give you 1. So if I pick a 1 here, it should spit out a 1. Okay. Pick something a little bit more interesting. Let's pick a 2. So 2 squared is going to give me a 4. Now we're really cooking with fire here. All right, so that's going to be that half of the graph. So I have 1, 1, in case we forgot our coordinates, and 2, 4. So I go over 2, and I go up 4. I believe the 1, 2, 3, 4. Yep. And you know, just a pro tip here, early in the video, but pro tip: these guys, if they don't have anything in front of the x squared, right? So nothing in front of parentheses, nothing inside the parentheses. This guy actually goes up 1, goes up 3, I think goes up 5 next. Let's try it. So we have a 3, and then f of 3 is equal to 3 squared, which is equal to 9. So yeah, it goes up 5, and that's going to be off of our graph, but we'll just estimate it. So let's try some other points. Let's try -1. Okay, so I have a -1 squared, excuse me. That's going to give me a positive 1, right? -1 times -1 is a positive 1. So a -1 here is going to result in a positive 1 on that side. And last thing, -2 is going to be -2 squared, which is going to give me a 4. So I have a -2 and a 4 on that side. Okay, so I'll go over here. First point, I plugged in a -1, so I go back 1, up 1, and I go over 2, 1, 2, and I go up 4. Look at that. It is symmetric. That is interesting. So then, let's see if I can get a nice, kind of a thicker line here to work with. Just so we can kind of see what's going on. That line is going to be like that, sort of, and this guy, like that. Okay, so that's going to be our parent function of f of x squared.